tiger's roar is one of the most powerful vocalizations in the animal kingdom, capable of being heard up to 3 miles away in the right conditions. This deep, resonant sound is a crucial tool for communication, allowing tigers to establish territory, signal their presence, and even intimidate rivals. But would a tiger's roar sound the same on the moon, where there is no atmosphere to carry sound waves? Sound, as we know it, travels in the form of waves through a medium such as air, water, or solid objects. The speed and propagation of sound are entirely dependent on the medium it travels through. On Earth, sound waves move through the air by vibrating molecules, but space is a vacuum, meaning there is no air to carry these vibrations. Without air, a tiger's roar on the moon would be completely silent to the human ear. The moon lacks a significant atmosphere, meaning it does not have air molecules for sound waves to travel through. When a tiger roars on Earth, sound waves move by vibrating air molecules, allowing them to reach our ears. In space, however, there are no air molecules to carry sound. If a tiger were to roar on the moon's surface, there would be no medium for the sound waves to travel through, resulting in complete silence. This absence of sound transmission is a fundamental principle of physics. In space, the vacuum prevents molecules from colliding and transmitting vibrations. Sound is a mechanical wave, which means it needs a medium, such as air, water, or a solid surface, to propagate. Since the moon lacks a substantial atmosphere, sound waves have nothing to move through, rendering any sound inaudible. This principle applies not just to a tiger's roar, but to any sound that relies on air to travel. However, if a tiger were inside a pressurized lunar habitat, its roar would be audible, though it might sound different due to the altered atmospheric conditions. The moon's surface pressure is virtually non-existent, and sound travels by vibrating air particles. On Earth, sound waves move through air at about 343 meters per second, but on the moon, there is no air to carry these waves. If a tiger were to roar inside a pressurized habitat filled with an Earth-like atmosphere, the sound would travel in a familiar way. Sound changes depending on the medium through which it propagates. If a tiger somehow roared in an environment with a much thinner atmosphere, such as the moon's exosphere, there would be no air molecules to transmit sound waves in the way we experience on Earth. Instead, any sound produced would be inaudible in the vacuum of space, and only vibrations within the tiger's body or ground could be perceived. Although a tiger's roar cannot be heard in a complete vacuum, sound waves can still travel through other mediums, such as solid materials. If a tiger were to roar on the lunar surface, the sound waves could be transmitted through the moon's solid ground rather than through the air. This is similar to how seismic waves travel through the Earth's crust. If an astronaut stood near a roaring tiger on the moon but was wearing a spacesuit, they would not hear the roar through the vacuum. However, if they were touching the ground, the vibrations might be felt through the lunar surface. The sound might also be faintly heard through the astronaut's suit, but only in a very limited way. Astronauts who have ventured into space confirm that they hear nothing from outside their helmets while on the moon's surface. During the Apollo missions, astronauts communicated with each other through radio transmissions. They could not hear any sounds from their surroundings due to the vacuum of space. This would apply to a tiger as well. If a tiger were to roar on the moon without an atmospheric medium, the sound would not travel through the empty space to be heard by another observer. However, if a tiger were placed inside an environment with an artificial atmosphere, such as inside a space station, its roar would likely sound different. The density and composition of the air in an artificial habitat on the moon would affect how sound travels. On Earth, our atmosphere consists primarily of nitrogen and oxygen, while the moon's surface lacks a natural atmosphere. If a tiger were inside a pressurized habitat with an Earth-like atmosphere, its roar would sound more similar to how it does on Earth. On Earth, a tiger's roar is influenced by a variety of factors, including the density of the air, humidity, and temperature. These elements affect the speed and wavelength of sound. Sound moves faster in denser media, so on Earth, a tiger's roar has deep and powerful low frequencies due to how sound waves interact with the atmosphere. On the Moon, sound waves would not propagate in open space. If a tiger's roar were transmitted through a medium like a space station's air-filled chamber, it would still be audible, but would depend on the specific atmospheric composition. In an absolute vacuum, sound waves cannot travel, making vocal communication impossible. If a tiger attempted to roar outside on the lunar surface, the roar would remain trapped inside its own body, with only internal vibrations being felt. However, astronauts in a lunar habitat with air could still hear a tiger's roar just as they would on Earth, though subtle changes might occur depending on atmospheric pressure. The Moon's gravity is about 1/6 of Earth's, which could also affect the tiger's ability to generate the same kind of powerful roar it would on Earth. Since sound is produced by the vibration of vocal cords due to airflow from the lungs, the absence of atmospheric pressure on the Moon might alter how sound is generated within the animal's throat. The roar could potentially be weaker or sound different within a lunar environment that has no atmosphere to support full sound wave propagation. Moreover, sound waves in space are affected by the medium they travel through. On Earth, sound waves travel through air at a speed of about 343 meters per second. However, in a different medium like the dense atmosphere of Venus, sound would travel much faster. If a tiger were in a high-pressure environment, the speed and nature of the sound would change accordingly. One experiment conducted on the International Space Station revealed that sound does travel in a contained atmosphere, but at a different speed due to lower air pressure. If a tiger's roar were to be heard inside a pressurized lunar habitat, it might sound different, likely higher-pitched and less resonant than on Earth. The reduction in atmospheric density might cause a decrease in the sound's intensity, making the roar seem more muffled than it does on Earth. While we have yet to test how a tiger's roar might sound on the Moon, some data comes from experiments with sound in vacuum chambers. Scientists have recorded the changes in how sounds behave in different atmospheric conditions by testing how frequencies shift in low-pressure environments. These experiments suggest that while sound may still be produced inside a sealed chamber, it will not travel the same way it does on Earth due to differences in atmospheric composition and pressure. The study of sound transmission in space has practical implications beyond scientific curiosity. Understanding how sound waves travel in different atmospheric conditions could help design better communication systems for future space missions. It also sheds light on how the human body and other living organisms adapt to space environments. Big cats have evolved to rely heavily on their roars for communication, establishing territory and signaling their presence. However, if transported to a space environment, their roars would be completely inaudible outside of a pressurized chamber. While we have yet to fully understand whether big cats can sense geomagnetic disturbances or changes in space weather, their extraordinary senses make them prime candidates for further research. Studying how big cats and other animals respond to space weather changes could provide new insights into both terrestrial and extraterrestrial biology. While the idea of a tiger's roar on the Moon may remain purely hypothetical, it invites fascinating discussions about the broader implications of space weather on Earth's creatures.